You just see this, there is a developer tool.
Cut it. Cancel. Okay, do this.
We'll skip this practice because we can do it later.
Can't select them. Cancel this.
Others, have you this developer? No, help him to get a developer.
File options.
File option.
There is no options in this.
You go there. Just go there.
नहीं वो कहीं और होगा. फाइल
अच्छा
ऑप्शंस नहीं है.
options नहीं.
Nila, you are having a developer.
View
Parth having.
Yes sir, वो
Very good.
इसमें तो ये
ठीक है, we will check it later. You just write down others. It is there?
नीले.
No. We will check it later. Sir is having.
हाँ सर.
if you do.
Okay. So you click the developer. Click the developer icon, then after developer what you will get? This one, controls. There are so many controls, you just insert. There is a insert controls. Insert controls. And in this insert controls there are one icon for scroll bar, and like that you put it will get, you will get a scroll bar like that. You write down now in your notebooks. We will check who is not getting this one. Okay. This developer, insert controls, and then scroll bar, and you will get a scroll bar like that. Just you have to click, and there will be a values. Depending on these values, it can be 5 or something. So you can drag this left side or right side.
In the rotation exercise, when we rotate, the rotation is about the origin, right?
Yes.
So that is why you might see a shift in the coordinates of each point.
Yes. It will automatic shift. No?
Shift, yeah.
Automatic
Yeah,
shift.
so,
And sine cos will take care of that.
so if suppose I want to rotate about the centroid of the object,
Anywhere now, control is in your hand, and that too with these 4 elements, and that all these things will be covered in our
because
session.
ultimately the rotation matrix that
You keep
specified
it in your mind and do it.
is about origin.
Yes, yes.
Is about origin.
We will change from anywhere. So this is the scroll bar. Everybody got a scroll bar, and then scroll bar right click, and then format scroll bar. Right click and format scroll bar. You just select that. Format controls, sorry, format controls, not scroll bar. Everybody finished, and this when you click it, it will give this format control, and here maximum value you put your rotation will be 360 degree. So you put it 360, and then increment change is 1, you keep it 1, it will be very slowly move. You can later change experiment 5, 10, 11, the faster you want to change, and then you write down others so that you can practice later. And cell link, you have to link these values to a cell. So, we will select it C1. So, when you click this scroll bar, you see this how this is moving, these values are changing 22, 23 like that. Everybody getting this?
What is the page change parameter supposed to do?
Page change, this is having some special requirement, but we will not.
So, what should value should be put over there?
Oh, let it be 10, I think. This
Okay.
will.
And the 3D shading, should we keep it there?
No, no, not required. That is for all for ornamentation and special requirement. So, we will not deal with this now. So, scroll bar, have you got everybody? But as we told that it is giving a in degree, we should change it to radian. So, what will be the formula? Is equal to this divided by 180 pi, enter. So, 70 degree is equal to 1.22 radian. So, we want that.
Some center plus r equals to r.
Yeah, brilliant.
So, it is rotating your triangle as
Yeah.
per scroll bar.
Absolutely.
Everybody? Very good, very good. So, this is the dynamic wall you have entered. Now, you are using scroll bar for, you are not entering individual things. Now, we have achieved, we have reached some point. Now, we had ABCD matrix. So, you have changed your I have rotated your triangle, everybody. Now, earlier when you are doing, what you are getting? Your triangle used to get getting deformed, but when you are rotating, what is happening?
It is just rotating, no change in shape.
Not changing in shape. But if you see, our elements are ABCD, but here this not changing the shape, and when I was scaling or doing something shearing or reflection, it reflection also shape will not change, but scaling and this shearing shape was getting changed. So, how I can ensure when the shape will get changed or not? How can I ensure? Anything in matrix chapter, have you read anything about that? How we can ensure that whether the shape will get changed or not? Any idea? Anybody?
If the determinant is 1, then the shape will not change.
Very good, very good. This is the answer, determinant. So, whether how I will be knowing that shape, when will shape change or not here? Just we will find its determinant, and for that determinant we will not go for the tedious method of calculation. We will use technology. What is the technology? Is equal to mdeterm, I think this is the command. Minus 5. So, here I will get minus 5, but when this when we will be you try to apply with your rotational matrix, you try to make it in rotational matrix and you will see that what values you get. Determinant of your rotational matrix, what is that?
1. We'll get 1.
1. So, this is called this type of matrix, what is called? Orthogonal matrix. Orthogonal matrix. And orthogonal matrix is what is the property? Its inverse is its transpose. So, indirectly we are exploring the linear algebra. All these topics are linear algebra, but the way we taught linear algebra, we never see that what happens in these cases. Yes. So, this is orthogonal matrix, you can write down there. Orthogonal matrix, if the determinant of that matrix is 1, then there will be no shape change. Okay? Shape will remain intact. So, this is the case for rotation and reflection.
And we can see the gradual rotation.
So, this is how you feel that is about the origin is very clear.
Now, what we will do, I told you this orthogonal matrix transpose is equal to is inverse. So, what does it mean? I will explore that just and for that also we will use technology, we will find out the inverse of this matrix, what is given. Formula is M inverse. You see that formula automatically appears here. So, now we will find the inverse of this matrix. Inverse of matrices, oh sorry, you have to select same size of matrix, then only you will get. So, you see this inverse of this matrix. I have calculated the inverse and transpose of this matrix 3 4 2 1. and it is seen that in my case this transpose and inverse matrix are different, but I think for if in your case the transpose and inverse is same. So, what is the advantage of knowing this information? How you will use this information? This is having a very big advantage, because calculating inverse of a matrix is very tedious process and very complicated process. But if you know that some matrix which is equivalent to its transpose, transpose is means row and interchange row and axis, that is all. So, those mechanically if you are given, you will just first try to calculate inverse, but before that you just calculate what is called determinant. If it is 1, you just transpose. So, this is also a tricky situation in entrance examinations. They are by seeing all these things, by applying all these things, sometimes without solving you can answer many matrix problems. So, going back to our discussion, rotation is over. So, now others, can you tell what are the transformation we have covered?
We have covered scaling,
Yes,
reflection,
yes,
then shearing,
very good,
then rotation.
very good.
Then
बस हो गया.
हाँ बस हो गया.
projection.
So, we have covered four transformation, and we have not covered okay. Here you see the issue is that how easily with 2 by 2 matrix we have covered all 4